Black math! Give me some math and I'll give you some flack. Black math!
We are going to do lesson 37 and 38. We'll start with 37 because that comes before 38. And we're going to talk about, we're going to find the area of a triangle. And then we're also going to do more rectangles, but this is more of a more advanced, I guess. Rectangles part 2 is a good way to put that. Okay? So, if you think about a triangle, so here's like a classic triangle. This is actually a right triangle because it has a right angle in it. A right triangle is always half of a rectangle. So if I went like this, boom, boom, then that would be a rectangle, right? So if I had dimensions like an 8 and 5, so if I wanted to find the area of the rectangle, then it would just be length times width, right? Base times height. So 8 times 5. Well, I want the triangle. So to find the triangle, then it would be half of that. So how do you find half of something? You go half. So 8 times 5, and then you cut it in half, divide it by 2. So the rectangle is 40, but the triangle is 20. So there's a formula to find the area of every triangle. So area of triangle, and this is probably what most students forget, is dividing by 2. So it's base times height divided by 2. So the B and the H stand for base times height. Okay? You can also just, if you want to just find half of a rectangle, you could write it like this, or 1/2 base times height. Okay? So that's the same thing. If you multiply something by half, that's the same thing as dividing it by 2. So half of 10 is the same thing as 10 divided by 2. Okay? All right, so now it kind of depends on what the base is and what the height is. I guess we could tilt this on a side here, so put it on the left side here. And then we'd have a base of 5 and a height of 8, right? If we tilted it up. But you still get the same answer, right? Base times height divided by 2. Instead of 8 times 5, it's 5 times 8 divided by 2. So it's the height because we call this the perpendicular distance from bottom to top. So if this was a weird looking building and you jumped off of this building, so maybe it's a 5-foot building, so you wouldn't die. Okay, so don't jump off like a 50-foot building. You can jump off a 5-foot building, but wear pads just in case. So that is how high it is. Even though this is a weird side over here, this has nothing to do with the height, okay? So if you had a triangle that looked like this, well, what's the height of that? Like, that's kind of a wonky base there. But it's hard to tell the height because this is not the height. This is not the height, but this is the height. So if they want you to find the area of this triangle, they're going to have to give you this number here. So if this was like a 10 by 5, then it would be area equals base times height divided by 2. So 10 times 5 divided by 2. So 50 divided by 2 is 25. Okay? Does that make sense? All right, so remember, this is not the height. This could have been like 7 or something. They might put it in there to try to confuse you, but do not multiply 10 times 7. They might have that in there because they might say, find the perimeter and the area. So if you find the perimeter and the area, then you need that 7 and the 8 for the perimeter, but not for the area. Okay? Does that feel all right? Do you guys remember doing this before? Have you found the area of triangles before? Not much? Okay, well now you get to. You guys are all grown up and calculating area. So proud of you. Next thing you know it, you're going to be driving Okay, so it's nice when it's a right triangle. And we talked about right triangles. And we talked about acute triangles and obtuse triangles. There is an activity in this book which you don't really need to do, but it's kind of cool because it talks about and demonstrates the area of a triangle pretty easily. Okay, but we're not going to do that activity. So the biggest thing that you guys need to remember is area of a triangle equals base times height divided by 2, or 1/2 base times height. Okay? Do you think you can remember that? The most common mistake, I see this all the time, is people forgetting to divide by 2. So don't forget to divide by 2 or multiply by 1/2. Okay, if that feels okay to you, let's move on to rectangles. This is area of rectangles part 2. Okay. Actually, let's do one. Can I just do one more example of finding the area of a triangle? This time, if I had like an obtuse triangle, which looked like this. So here's my base, but how do you find the height? Now, how far would you have to fall off of this building? Well, where's the top? The top is right there. So if I go straight down, this sounds so morbid. Please don't jump off buildings. If I went straight down, this is the height, okay? So you can't find it anywhere inside. So the height is not anywhere inside this obtuse triangle. They have to give you this number. And it'll be pretty obvious in your homework to find the area, because it'll be, what's that weird dotted line thingy outside of the triangle? Well, the only reason they do that is to tell you how high it is. So if this is 4 centimeters and this is 5 centimeters, hold on a second. 5 centimeters, and this is 7 centimeters. What's the area of this triangle? Yes. What is it? 10, did you say 10?
Yes.
Nice work. Okay. So I tried to trick you. I wonder if someone's going to multiply 5 times 7. Did you guys do that in your head? You don't have to tell me. You don't have to tell me. I won't think less. Hey, I'll think less of you a little bit. But it's a good, healthy thinking less of you. Okay? Because if, it's okay. It's okay. I'm not going to judge you. That's the better way to think. I'll think less of you, but I won't judge you. Okay? So 4 times 5, or 5 times 4, because 5 is the base and 4 is the height. So base times height, 5 times 4 divided by 2 is 10. And what's our label? So not, I don't know. I didn't hear all of that, but it's not centimeters, it's square centimeters, right? Because if you think about it, when you're multiplying, 5 times 4 is 20, but you're also multiplying centimeters times centimeters. Centimeters times centimeters is centimeter squared. Okay? When you're doing perimeter, it's just centimeters, because 5 centimeters plus 4 centimeters plus 7 centimeters. You don't multiply those. You just add them together because they're like terms. But anyway, those are triangles. Can you guys do that? You guys feel good about that? Okay. Let's do a little bit on some more rectangles here, and then we'll move on to lesson 38. So I'm just going to put an example up here, and I want to find the area of this bad boy. Oh, what is he doing? What is that? What's going on? Okay, have we found like the perimeter and stuff of things like this before? Yeah. So we can find the perimeter. We could probably find the perimeter of this if we wanted to. Even if we don't know these dimensions, we could probably still find the perimeter, right? Because you could add just 2 23s, because you know that this has to equal whatever 23 minus 10 is, so 13. But you didn't really have to subtract that, because you know that these two sides had to add up to 23. So you got the top sides and the bottom sides all add up to 23 plus 23 is 46. And then this is, if this is 7 and this is 12, then this has to be 5. But either way, they both have to add up to 12. So you got two 23s and two 12s. So 46 plus 24 is like 70 inches if you're finding the perimeter. But we're not finding the perimeter. We are finding the area. So there's a few different ways to do this. So what I'm going to do is I'm going to try it 3 different ways. Okay? And normally if I was there, I would have you guys come up and show me what you would do, but there's 3 different ways. So I'm going to start with the blue way. Let's do the blue way. The blue way is, I don't know how to find the area of this weird looking chubby L, right? But I do know how to find the area of rectangles. And this is a 12 by 10 rectangle. What's 12 by 10? 120, right? I don't know if some of you said that, but I can't hear you. And then what's this? Now I do need this dimension. What's this dimension? How do you figure that out? Yes, Adeline.
You subtract 10 from 20.
Nice. Okay, so this is 13, right? All right, so let's multiply. This is a 13 by 7 rectangle. Oh, I hate 13s. Okay, so I think that's 91. That feels right. Okay, so is that the area? Well, now we have to add it, right? So we add that triangle, 120, that rectangle plus that rectangle. So now we get 2, 11. Is that what you guys got? Yes? No? Am I wrong? Because if I'm wrong, you get a free problem set if you tell me. All right. I guess I'm right. All right. Now, that's one way to do it. Can anyone describe to me another way to do this problem? Oops, not 7. Anyone know another way to do this problem, to find the area of this? So I don't know how to find the area of this chubby L, right? But I do know how to find the area of rectangles, right? So that's one way to make 2 rectangles. There's another way to make 2 rectangles. What is it? Do it with your finger. Yes. Just cut off its head. Ew. Don't do that. That's violent. Okay, so now I can find the area of this guy. 23 times 7. That's annoying. I think it's 151, but I could be wrong. Okay. Yes, I am wrong. It's 161. Did you guys catch me before I did? All right, 161. All right, so what's the area of this? Well, I need this dimension. What's that dimension? You can show me with your hand. Nice, Harvey. Okay, 10 times 5, that's a 50. So let's see what happens when I add these 2 rectangles together. What do you think is going to happen? What number do you think I'm going to get? 211. Boom. Same. Check. All right. Believe it or not, there is a third way. I always refer to my ADD kids on this one because sometimes we need a special thinker to figure out the third way to do this. And I always think weird because I'm a little ADD. So if you are ADD, show me your superpower and tell me a third way to do this, find the area of this. It's kind of a backwards thinker, backwards thinking, like you're coming in the back door. What is it? Oh, I see a hand in the back. Who is that?
Grady.
Grady, what are you doing?
So instead of going to all the numbers, take the 2 dots on 23 and 12.
Yeah, so I think this is what you said, but find the area of the whole thing? Is that what you said?
Yeah.
Yeah, and then you just cut out that rectangle. So what you want to do is you want to find the area of this big rectangle, and then you want to subtract that little guy in the corner. Okay? So let's do 12 times 23. Ugh. 10 times 23 is 230 plus another couple 23s. So 230 plus 46 is 276 minus, what's this little guy? What are the dimensions of this little guy? 13 by 5, right? Well, that's 65. 13 times 5 is 65. So what's 276 minus 65? 211. Nice work. You see how that works? So you just have to know one of these ways. And sometimes this won't work. This way won't work, this backwards way. And sometimes the only way you can do it is one of these two ways. But there are a lot of times where none of these ways work and you have to think backwards. So I call this the carpet layer method. So this is a dude laying carpet. Instead of cutting two different pieces of carpet, that's annoying because carpet layers hate seams. So they just put one big piece of carpet down and then they cut out what they don't want and they use this for scrap somewhere else. Okay? So either way works. Either of these three ways work. Just do it one way, okay? Should we try one? Let's see if you guys can figure out the area of this. So let's do one for you guys to do. This is example 4. So find the area of this. Okay, it looks a little cartoony. Sorry. It's not nice and rectangular. What?
It looks like a butt.
Looks like a butt?
A butt.
What kind of butt does that look like? All right. Oh, it looks like a bug. Oh, I don't know. I don't want to know. Bus. Oh, a bus. Oh, I see. And then the wheels on the bus go round and round. Yeah? Okay, that's confusing now. All right, see if you can find the area of that. Go. Ooh, I see a hand raised. Already? Who is that?
That's me. Is it 170?
170. Let's see. Did anyone get anything different? Anyone want to argue?
I got 190.
All right, let's see. Let me see what I get here. I'm gonna do it this way. This is the first way that comes to mind. So this is, if that's 10, that's 5, then that's 5. So let's see, that's 70 there. And then 20 by 5 is 100. Yes, 170. So the area is 70 plus 100, which is 170. Good job. And then what is it? I guess we need a units, don't we? If it's meters, so square meters, right? Okay, good, guys. Does that feel all right? Thumbs up, thumbs down, thumbs up. Okay, good job. Harvey, don't be so excited. Like you're just out of control hyper right now, Harvey. Look at you. Okay. Let's move on to 38. So this is nice. We are going to talk about graphs. I think we briefly discussed it, but this will be a pretty quick lesson. We just need to know how to read graphs and eventually construct graphs. But let's have a look here. So I think what I might do, I'll just rewrite. I'll rewrite it. I was going to show you my book, and I think I'll just rewrite it on here. Okay, so we use graphs to help us understand quantitative information. Okay, it's just a nice visual to see what's happening with numbers. Most of us are more visual learners than audio learners, so it's nice to be able to see it. So let me just start with an example. This is an example of what a graph could look like. So this is graphs. Example 1. So if I have January, February, do you guys say February or February? Because phonetically, it's spelled with February. That's annoying. I used to try to say February for a while, and I just felt like I was saying it wrong, and I felt silly. So I just say February now.
Yeah.
Will you guys judge me if I just say February? Do you guys say February or February?
February.
I'm just going to say Feb. Feb is great. Okay, so let's talk about these donut shops, or just one donut shop. And let's say one circle. So here's the donut. So I'm going to say on the bottom here, this represents 10,000 donuts. I just got a little sick to my stomach for a second, just imagining myself trying to eat 10,000 donuts.
I could probably do that.
Yeah, I mean, I'm not going to back away from the challenge, mind you, but it is, I just was trying to ready my stomach to even think about that. Okay, so if one donut represents 10,000 donuts sold, how many donuts were sold in January? Adeline?
40,000.
40,000 donuts. Oh my goodness. 40,000 donuts.
That's 10,000 a week.
That's we could do that. Now that you say it that way, that's doable. Because if we got a whole month to eat 40,000 donuts, I think we could do that. It's not impossible. All right. What about February? How many donuts were sold and probably eaten in February? All right, Marin. 60,000. Did you say 6,000 or 60,000? All right, 60,000. Okay, all right, let's look at March. I'm going to try to trick you. So I think maybe our donut eaters were feeling a little guilty about eating so many donuts. So sales went down a little bit in March. That's cool. Whatever. I guess March is a good time to go on a diet. You're getting ready for summer. I want to fit into that bikini, you know. So about how many donuts were sold in March? Harvey?
50,000.
Did you say 50? I heard a 50. You probably said the right answer, which is 55,000, right?
Okay.
Did you say 50,500?
I said 3.
Okay, that's all right. Good job. 55,000. That's it. So if one donut represents 10,000, then a half a donut represents 5,000. So 50,000 plus 5 more is 55,000. That kind of makes sense. Okay. So that's a cool looking graph. We don't really have a special name for that. It's more of like a picture graph. But we do have other types of graphs. One of them is called a bar graph. And you've probably seen this. So if I took my same information and talked about donut sales, I could still do the same type of data. So let's say sales in 10,000s on the left here. And then months, so January, February, and March. So if I said 10, 20, So, I'm not going to say in 10,000s. I'm going to say like in thousands or something. 30, 40, 50, 60. So what was my January sales? 40,000, right? So if I'm gonna put a line right there and like make a little bar. Looks pretty. Fill it in. Yay. So that's 40,000-ish. And then February was 60,000. So I'm going to put a line up here at 60. And make a graph there. Blah, 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 blah. And then 55. So I'm going to go in between 50 and 60. It's about right there. And put my graph there. Does that make sense? So same data. You can look at it however you want. I like seeing the donuts. It makes me feel better seeing a donut instead of a bar. Well, I guess like a good maple bar, those are good. Especially the cream-filled kinds. Can't go wrong with those. Nice. Okay. So that's a bar graph, okay? So you need to be able to construct this and to read it. So you need to be able to say, oh, okay, in February there were, let's see, it goes up to 60. Oh, and it's in thousands. So 60,000 donuts. Whoa. Okay. So that's example 2. Any questions so far? Does that make sense? Everybody okay? Okay, look at example 3.
Do you have a question, Adeline?
Yes.
Oh, yes, Adeline. Sorry, Adeline. What's up?
Sorry, I forgot my question.
All right. Well, if you think of it again, raise your hand, okay?
Okay.
All right. So the third kind of graph I'm going to show you is called a line graph, or sometimes it's called a broken line graph. And I'll tell you why it's called a broken line graph, but you could do the same data. So we got our January, February, March, and we could still have our same data here, same scale in thousands. I mean, you could just write it all out like 10,000, 20,000, but this is done a lot too where it's in thousands, sales in thousands. Okay, and then you'll have a label down here, maybe right here that says month. Okay, so instead of a bar, we're just going to put a dot. All right, so then, and we're just going to leave that and then go to February, which was 60,000. So instead of a bar, we're going to put a dot, and then March at 55. And then what we're doing is we're just going to connect the dots. Okay, and that was poorly done, sorry. But a lot of people use line graphs so they can kind of see like the trends on how when it goes up, when it comes down, and things like that. You can still see that like on a bar graph. Like you still see that it goes up and down here. But this stands out immediately that, okay, what happened between January and February? Did we get a new donut? Did we put like bacon on a maple bar or something? And oh my gosh, that sounds so good. So then they look at this and they say, okay, what happened between January and February? So it's nice to see that improvement, see that line go up. And over here, okay, what happened between February and March? Like, what's going on? What happens between February and March? Why do people hate donuts?
They got bored of them.
Oh, yeah, they got sick from the bacon, I guess, in February, and so they couldn't eat anymore. Okay? There's really just one more type of graph, and this is called a circle graph or a pie graph. This is a nice graph to have if you are wanting to see just out of a hole what is happening. So, for example, hi.
Kara has a question about bar graphs before you move on.
Okay.
I had a question about the line graph.
Uh-huh.
Do you put a dot like when it goes, but every time it goes up and down, or
No,
does
it's
it
just
like?
Yeah, so this is the data point here. You just put a dot like somewhere in the middle there, like at the 40. Put a dot there. And this is what I forgot to tell you too, is the reason why they call it a broken line graph, it would probably be better if it was like a fracture, I guess. I don't know, maybe a broken. But you know when you break a tree branch and there's still bark holding on to it? So when you break a tree branch, it doesn't separate. So this is kind of like I took this nice straight line and I broke it in places, you know? So that's why they call it a broken line graph as well. But you could just call it a line graph, okay? Now this pie graph here, this could literally graph like how many pieces your family had of pie, okay? So for example, if this is pecan pie, I would have this whole half here, okay? And then maybe my son would have this section, and then maybe my wife would have that little piece, if I let her, okay? But that could literally represent, out of the whole pie, how much went to Mr. Flack, how much went to his son, how much went to his wife. But they use this for anything. You can use this for, in this example, is where Dina spends her day. Okay, so for example, she might be at home for 12 hours. Dina, get out of the house. Get some exercise or somewhere. Okay, and then maybe she's at school. Well, I guess that includes sleeping, doesn't it? So I guess she's all right. She can spend 12 hours at home. Because what, you spend like 8 hours sleeping and then 4 hours not sleeping at home? That makes sense. Let's say Dina's at school for 8 hours. And then the rest is elsewhere. Okay? So how many hours would elsewhere be? Yeah, because there's only 24 hours in a day, right? So this, see how this represents all the hours available, okay? So sometimes you would see a circle graph, and instead of numbers, well, you would have numbers, but instead of these numbers, you might have percentages. So this could be like 15%. This could be 40%. Maybe another 15%. Where are we at? 55, 70. Maybe here's a 5%. Here's another 12%. I don't know, 13%. So technically, all this should add up to 100. I don't know if I did it. 60 plus 30. Nope, I didn't. I'm going to make that 25%. Now it does. Okay? So a lot of times you'll have percentages because it all has to add up to 100%. So maybe this is your budget and this much goes towards groceries. This one goes towards rent or things like that. Okay? So a pie graph or a circle graph is used to be able to visualize parts of the whole. Okay? So the whole thing, this is the whole pie, and then this little slice goes towards this little slice goes this. So it's a nice graphical representation. Again, you can do that on a line graph and a bar graph, but you don't need to see like how far it is from being at home than being at school. That's kind of silly. So a bar graph or line graph doesn't really help that much. But a pie graph or a circle graph allows us to compare as a whole how much that takes up of the pie than others. Yes, Harvey.
The circle doesn't add up to 100. It goes over.
It doesn't add to 100?
Yeah, it goes over.
Okay, let's see if it's 40 plus 20, 60 plus 25 plus 25. You're right. I was right the first time. Harvey, you get a free problem set. Nice work. So I'm going to add that digitally to your thing here. So 106. Oops. I just gave you 101,061.
I'd be fine
That's a
with
lot
that.
of free problem sets. All right, good job. So that's pretty much it on bar graphs and line graphs and circle graphs, picture graphs. So yeah, so you do have a few minutes left here, guys. You have about 20-ish minutes. What we did with the last class, if you want to try to get some problems done, you can. If you get 10 or more problems done, you get a flak attack point for each one. So if you do 10 problems, you can let Mrs. Felmley know, and she will write it down and let me know who gets what, okay? All right, any more questions? Adeline, did you think of your question?
No.
Okay, that's all right. You can message me later if you need to. But,
Thank you, Mr. Black.
yep, it's good to see you guys. Have a good weekend. We'll see you soon.
Black man, give me some math and I'll give you some flack. Black man.